You know, for centuries, we've talked about mental illness as this ghost in the machine, something that's invisible, maybe not even entirely physical. But what if it's not a ghost at all? What if these conditions leave actual physical traces we can see, footprints inside the brain itself? That's what we're digging into today.
So let's just get right to it. This is the big question, isn't it? Forget all the metaphors and abstract ideas for a minute. If you could actually hold a brain affected by a major psychiatric disorder in your hands, what would you see? What would be different?
And this is where the mystery really begins. It's a tale of two brains. On one hand, you have a neurological disease, like Alzheimer's, and the damage there is, well, it's tragically obvious. You see widespread decay, plaques, lesions. But then you look at a brain with a psychiatric illness, like schizophrenia, and to the naked eye, it can look surprisingly normal. The changes are so subtle that for a long time, people argued if they were even there at all. And that's our detective story.
So, to crack this case, we're going to zoom in on one specific file: schizophrenia. Scientists have been chasing down clues on this one for over 100 years, looking for that physical evidence.
And I mean, this is not a new hunt. This goes way back. We're talking Alois Alzheimer himself describing subtle changes way back in 1898. But for decades, the results were all over the place, and a lot of people just wondered if it was a dead end.
But then our technology got better, and as it did, a really consistent pattern started to pop up. Postmortem studies began to show, again and again, this small but significant reduction in the size of key brain areas, like the hippocampus.
Let's put a number on that, because it's important. We're talking about a consistent 15 to 20% average reduction in volume in these critical areas for memory and emotion. Now, it's not a huge, gaping difference, right? But it's real, it's consistent, and it's physical.
And it didn't stop there. As researchers looked closer, the list of clues just kept growing. They found other subtle things. The overall brain weight was a little less. There was a bit more empty space inside, and even the super intricate folding pattern of the brain's surface was different. The evidence was definitely piling up.
But here's where the story takes this incredible plot twist. Because the biggest, most important clue wasn't something they found, it was something that was missing.
Okay, so to get this, we need to know about something called gliosis. The easiest way to think about it is, it's the brain's version of scar tissue. When the brain is being actively damaged by something like an injury or a disease like Alzheimer's, these special cells called gliocells rush in and form a scar. It's like the brain's flashing red light for ongoing damage.
This star-shaped cell right here, that's an astrocyte, and it's one of the main scar formers. In a brain that's actively degenerating, you would expect to see these guys everywhere, working overtime.
And here